Hello and welcome to Maths with Jacob. This lesson will focus on Surds Part 2. As always, a special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. This is quite an unusual puzzle. See how you go with it. Surds. Rationalising the denominator. Surds can be written down in different ways. If a surd is written in the form of a fraction, it is much easier to deal with if the denominator is a rational number. For example, express 1 over the square root of 2 with a rational denominator. Now you can see that the denominator here is the square root of 2. That is irrational. Let's see how we change this fraction so it still has the same value, but it has a rational denominator. If we multiply both the numerator and denominator by the square root of 2, then the value of the fraction is unchanged. So basically the square root of 2 over the square root of 2 equals 1. So the overall value of this fraction is unchanged. So if we simplify this part here, 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is 2. So that is the new fraction, which has the same value, but notice it has a rational denominator. Now some prior knowledge. This is very, very important for the work we're going to do. Before we tackle the next part of this lesson, we need to make sure that an important piece of knowledge is available to us. It is known as the difference of two squares. In simple terms, look at how we expand the following. If you have two terms a plus b, and you multiply those terms by a minus b, that is, you have a sum and a difference, and you multiply those together. So here's how we expand that. A outside of a minus b plus b outside of a minus b. A squared minus ab plus ab minus b squared, which is a squared minus b squared. In other words, a plus b times a minus b is a squared minus b squared. Now, in a similar manner, if you had a minus b times a plus b, the answer is the same. You remember the commutative law for multiplication. It doesn't matter if you change these around, you still get the same answer. So this is a very, very important rule to remember, and it'll stand us in good stead for the rest of this video. Rationalising the denominator continued. Now we're doing another example which is slightly a little bit more involved, but the principles are the same. So we have the square root of 2 over the square root of 3. We multiply the top and the bottom by the square root of 3 over the square root of 3. Of course, that's 1. So the value of this fraction doesn't change. The square root of 2 times the square root of 3 is the square root of 6. The square root of 3 times the square root of 3 is 3. So from here to here, same value, but we have a rational denominator. That's the difference. Here is another example, slightly more involved. 7 over the square root of 5 minus the square root of 2. Now what we do, we multiply the top and the bottom by the square root of 5 plus the square root of 2 over the square root of 5 plus the square root of 2. Again, that's 1. So the value of this fraction doesn't change. Now, let's see what we get. 7 times the square root of 5 is 7 the square root of 5. 7 times the square root of 2 is 7 square root of 2. The square root of 5 minus the square root of 2 times the square root of 5 plus the square root of 2. That's the same as a minus b times a plus b, which is a squared minus b squared, which is really 5 minus 2, and that gives you 3. So there is your answer with a rational denominator. Now here's a more challenging example. We have to rationalise the denominator for this fraction here. So what we do is we multiply the top and the bottom by the square root of 11 plus 3 over the square root of 11 plus 3. The overall value here is 1, so it does not change the value of this fraction. It's still the same. So let's expand this top section here. That's the square root of 7 outside of the square root of 11 plus 3 plus 2 outside of the square root of 11 plus 3. Now, the denominator is, you have a minus b times a plus b, which is a squared minus b squared, which is 11 minus 9, and there's your 11 minus 9 for the denominator. Now, multiplying this part all the way through, we get rid of the grouping symbols. Square root of 7 times the square root of 11 is the square root of 77. The square root of 7 times 3 is 3 the square root of 7. Plus 2 the square root of 11, which is here. Plus 6, which is there. And 11 minus 9 is 2. And there is your new fraction with a rational denominator. Here's a quick quiz with 3 questions, very similar to the video. Please check through at any time to help you. The answer to the puzzle, West Indies. Isn't that cute? I've given you a little clue here in case you're not sure why that's the answer. Here are the answers to the quick quiz, and please check through the video as always. If you enjoyed this video, please subscribe on the next slide and you will receive a notification as to when the next video is available. Hope to see you next lesson.